Hey everyone, Linus here. Today we're diving into the world of processors, the brains of our computers. We'll be exploring how they work, specifically focusing on processor speed and something called pipelines. Don't worry, we'll keep it simple and fun. First up, processor speed. You've probably seen it advertised in gigahertz, but what does that really mean? In a nutshell, processor speed tells you how many instructions your CPU can handle in a second. Think of it like your heart rate. A higher heart rate means your heart beats faster, and a higher processor speed means your CPU can process information faster. Now, a single instruction could be anything from adding two numbers together to loading a web page. The more instructions your CPU can handle per second, the faster your computer can perform tasks. So, a 3 gigahertz processor can theoretically process 3 billion instructions every single second. That's a lot of computing power, but here's the catch. Processor speed isn't the only factor determining overall performance. Just like a well-trained athlete can outperform someone with a faster heart rate, other components and technologies play a crucial role in how your computer performs. And that's where pipelines come in. Stay tuned to learn more.
All right, we've got a handle on processor speed, but how does it actually work? Processors operate in cycles, kind of like a metronome keeping time. Each cycle represents a tiny unit of time where the CPU can perform a specific task. Imagine a chef chopping vegetables. Each cycle is like a single chop. A faster processor is like a chef who can chop incredibly fast, completing more chops per minute. More chops mean more veggies processed, and more instructions processed means a faster computer. Early processors could only handle one instruction per cycle. That's like our chef having to finish chopping one vegetable before moving on to the next. But what if we could make things more efficient?
This is where pipelines come in. Pipelining is a technique that allows processors to handle multiple instructions simultaneously, even though each individual instruction still takes multiple cycles to complete. Think of it like a car wash. In a traditional car wash, one car goes through all the steps, washing, rinsing, drying, before the next car can enter. With a pipelined car wash, as soon as one car finishes washing, another car can start, and so on. This way, multiple cars are at different stages of the car wash simultaneously, making the whole process much faster. Similarly, modern processors use pipelines to break down instructions into smaller steps, with each step handled by a dedicated part of the CPU. This allows the processor to work on different parts of multiple instructions at the same time, significantly boosting performance.
Let's imagine a factory assembling toys. In a non-pipeline system, each toy is assembled from start to finish by a single worker. This is slow and inefficient. Now let's introduce pipelining. We divide the assembly process into 4 stages, adding the head, attaching the body, putting on the arms, and finally packaging the toy. Each stage has a dedicated worker with the pipeline in place. As soon as worker 1 finishes attaching the head of the first toy, they pass it on to worker 2. Worker 1 can then immediately start attaching the head to the next toy, while worker 2 is attaching the body to the first toy, and so on. This way we have multiple toys at different stages of assembly at any given time, significantly speeding up the production process.
Section 5. Parallel processing, doing many things at once. Pipelining is a form of parallel processing, which essentially means doing multiple things at the same time. By dividing tasks into smaller parts and working on them concurrently, we can achieve significant speed improvements. Imagine you're making breakfast. You wouldn't wait for the coffee to finish brewing before starting on your toast, right? You'd multitask, getting several things done in parallel to make the whole process faster. That's the power of parallel processing. Modern processors use sophisticated pipelines with multiple stages, allowing them to execute instructions with remarkable efficiency. This is crucial for handling the demanding tasks we throw at our computers every day, from gaming and video editing to browsing the web and running complex software.
Section 6. The limits of pipelining, not a magic bullet. While pipelining is a powerful technique, it's not a magic bullet. There are limitations and potential issues. One such issue is pipeline stalls. Sometimes, an instruction in the pipeline might depend on the result of a previous instruction that hasn't finished yet. Think back to our car wash example. What if a car needs extra time in the washing stage? The cars behind it would have to wait, creating a stall in the pipeline. Similarly, in a processor, a stall means the pipeline has to pause until the dependency is resolved, potentially slowing things down. Despite these challenges, pipelining remains a fundamental technique in modern processor design, allowing our computers to achieve remarkable performance levels.
Section 7. Real-world impact. Why pipelines matter for your daily computing. So, why should you care about pipelines? Well, they have a direct impact on your everyday computing experience. Whether you're browsing the web, editing photos, or playing the latest games, pipelines are working behind the scenes to make everything faster and smoother. Imagine trying to edit a video on a computer without pipelines. The rendering process would be painfully slow, with each frame taking ages to process. Thanks to pipelining, video editing software can process multiple frames simultaneously, drastically reducing rendering times. The same goes for gaming, web browsing, and pretty much every other task you perform on your computer. Pipelines are essential for handling the massive amounts of data and instructions modern applications require, making our digital lives faster and more efficient.
Section 8. Beyond speed. Other factors influencing processor performance. While processor speed and pipelines are crucial, it's important to remember they're not the only factors influencing overall computer performance. Other components like RAM, storage speed, and graphics cards also play a significant role. Think of it like building a high-performance car. A powerful engine, processor, is essential, but you also need a robust transmission, RAM, high-quality tires, storage, and an aerodynamic body, software optimization, to achieve optimal performance. So, when evaluating computer performance, it's crucial to consider the entire system, not just the processor speed. A well-balanced system with a fast processor, ample RAM, and fast storage will always outperform a system with a blazing fast processor but bottlenecks elsewhere.
Section 9, wrapping up the future of processor design. As technology advances, processor manufacturers are constantly pushing the boundaries of speed and efficiency. New architectures, smaller transistors, and innovative techniques are being developed to squeeze even more performance out of our silicon companions. Pipelining will continue to be a cornerstone of processor design, but we can expect to see even more sophisticated implementations in the future. Who knows what incredible computing feats we'll be able to achieve with the next generation of processors. So there you have it. Hopefully you now have a better understanding of processor speed, cycles, and the magic of pipelines. Until next time, keep those CPUs humming